First target for Unit 11 is that you can identify whether or not a figure is a polygon and then classify the polygon. So a polygon has the following properties. It's formed by 3 or more sides that are line segments. So they have to be line segments. So for example, if I had a shape like this that had 2 line segments, but then had a curve on it, this would not be a polygon. Because it has a curved part. So any shape that has a curved part would not be considered a polygon. So a circle is not a polygon. Some people say this looks like an ice cream cone. We call it a sector. It's not a polygon. So anything that does not have, anything that has curved sides to it is not a polygon. The second point is that each side intersects exactly 2 sides, one at each endpoint. That means that it's closed and that it doesn't overlap at all. So this would be an example of a polygon. Kind of looks like a big V shape. Okay, each of the endpoints, each of the segments intersects at 2 endpoints. So for example, this one on the bottom left intersects at those 2 endpoints. Right above that intersects in the middle and top to the right of that. All of those intersects exactly 2 segments intersect at a single point. So yes, that is a polygon. An example of something that's not would be something like this, where it overlaps through the middle. So we have these different problem areas. So it cannot overlap. So is this a polygon? Yes, it actually looks a lot like the V that I drew. No problems there. Is this a polygon? No, has a curve to it. Is this a polygon? No, has an overlap to it where it intersects but not at the endpoints of the segments. And then we're going to classify polygons different ways. The one way I'm going to show in the video is convex versus concave. There's a few different ways you could talk about convex versus concave. The polygon on the left is convex, the polygon on the right is concave. If any of these 3 criteria can be shown to not work in the polygon, they'll make it concave. So it doesn't matter which one of these you use, or if you have another way of doing it, as long as you're comfortable identifying. So let's look at the blue. Blue says every interior angle is equal to or less than 180 degrees. So all of these angles on the inside of this quadrilateral are all less than 180 degrees. So that makes it convex. I'm going to show you the one angle inside the polygon on the right that is greater than 180 degrees, and that's what makes this concave. Usually when you see this angle on the inside that's greater than 180 degrees, you kind of have to wrap around. We could say that it looks like that side caved in. So that's how I remember concave, is that it looks like one of the sides caved in. Another way we could do is to look at it in green. Green says that every segment between 2 vertices is either inside or on the boundary. So if I highlight all the vertices in my convex polygon, this is saying that if I connect any 2 of those green dots, every single time I draw a connection, it's either going to be inside the polygon or it's going to be on the edge of the polygon. And that's it. Those are my only 2 things that could happen. That means that it's convex. Again, I'll show you on the concave where that fails. It's not that every line doesn't work. It's just that there's at least one line that doesn't work. That green line is outside the polygon. And so not every segment between 2 vertices remains inside. So this is a segment outside. So between 2 vertices, but it's outside, that makes it concave. A third one would be picking any of the sides and drawing it as an extension. So taking the side length and extending it all the way out in red. For a convex polygon, every time I do that, it stays outside the shape. So those red 4 lines create the polygon on the inside of those points, but the red lines themselves stay outside the shape. Again, on a concave polygon, I can find an area that if I extend aside, it goes inside the shape, and so that makes it concave. So that extends inside, that makes it concave. All right, we also talked about equilateral, regular, equiangular, and the different types of angle measures, or different types of sides, making a different type of polygon like a pentagon or a hexagon. So you want to review those as well. Number 1 is concave. Okay, we can show that this angle is over 180 degrees, or we can show that if we take this side and extend it, it extends inside, so it's concave. Same thing here, extends inside, or one of the interior angles is 180. Or if I connect 2 of the points, if I connect any 2 of the endpoints, it's outside. Number 3 is convex, because none of those issues happen. All my angles are less than 180 degrees. All my connections between the points are either on the boundary or in the boundary. And all of my extended side lengths are outside the boundary.